Okay, so tan of 2x is equal to sine of 2x on cos of 2x. So if we can end up figuring out sine of 2x and cos of 2x somehow out of De Moivre's theorem, then we're on our way, aren't we? Now just remember, sine of 2x is 2 sine x cos x. If you recall that identity, you should know. And cos of 2x can be expressed in various different ways, but most obviously it's cos squared x minus sine squared x, isn't it? Cos A, cos B minus sine A, sine B is cos of A plus B. So just that's the logic that I'm going to use, that tan of 2x is sine of 2x on cos of 2x. And I'm thinking, how does De Moivre's theorem relate to sine of 2x on cos of 2x? And of course, you can expand out cos of x plus I sine of x. You can expand that in two different ways. You can expand it using De Moivre's theorem, and you can expand it using the binomial theorem. So we're going to use those two different ways and equate them together, and we should be able to get our values. So let's first of all expand it using De Moivre's theorem, and it's just cos of 2x plus I sine of 2x. And then let's expand it using the binomial theorem. I'll just get rid of that extra s there. And expanding it using the binomial theorem, we've got cos squared x plus 2 cos x sine x times I, and plus I sine x is being squared. So it's a squared plus 2ab plus b squared, basically. So if I just neaten that up, we've got cos 2x plus sine 2x times I, and over here we've got cos squared x minus sine squared x for the real part, and 2 sine x cos x for the imaginary part. So once we get that, we can say let's equate the real and imaginary parts. I'll just write down equating real and imaginary parts. So equating the real parts together, we get cos 2x is cos squared x minus sine squared x, isn't it? Yeah. And sine of 2x is 2 sine x cos x. All right, so the question that we're asked to deal with is use De Moivre's theorem to prove the result that tan of 2x is equal to 2 tan of x on 1 minus tan squared x. So we had to use De Moivre's theorem to prove that. So I've used De Moivre's theorem to figure out what cos 2x and sine 2x are equal to by that logic there. So I'm going to say that tan 2x is sine 2x on cos 2x. Now I just need to get a bit more room here, so let's put a page break in. And I'm going to say that's equal to 2 sine x cos x on cos squared x minus sine squared x. And I look at my formula for tan 2x. I'll just write that down for you next to it here. Tan 2x equals 2 tan of x's on 1 minus tan squared x. So that's where we've got to end up. So can you see, if I divide by cos squared x, that'll sort the denominator out to be where I want it to be. So this is equal to 2 sine x cos x over cos squared x minus sine squared x. But we're going to divide both the top and bottom there. Going to divide by cos x there, and cos x actually by cos squared x there, and by cos squared x there. So that gives us 2 sine x on cos x over 1 minus tan squared x. So that's 2 tan x on 1 minus tan squared x. So I think that's what they were after. They were after us to get those identities there from equating the real and imaginary parts using de Moivre's theorem. And I could see my way ahead from previous knowledge that I was going to have to use those things to work it through.